Okay, so thank you everyone. So I'm the director of research at Stana Labs. We're an AI company in Stockholm, Sweden, focused on how to personalize learning at scale and to make it simple so that we can sort of scale it up and have it more commonly used. So we're a team of researchers and engineers with diverse background from, I was at Google AI research before, working on NLP and like deep learning for video understanding as well. And then we have folks from Spotify, work on music recommendations, consultants from BCG Gamma, or ex-consultants that now work for us. And data science from Imperial College London. So our mission is to bring the benefits of AI to learning. So if you look historically at education, we always have to focus on the average student. So teachers have sort of tried to adapt to multiple students, but you have a lot of students who cannot really adapt to all of them. So you have to sort of teach to the middle. So that means that you have one group of students who are bored, and you have another group of students who constantly fall behind because their knowledge gaps accumulate over time. But if you look at sort of what's happened in the last decade or so, and with sort of the advance of AI technologies in other aspects of our life, so for personalized recommendations for music and videos and so on, and search and smart assistants, so we think it's time sort of to bring these benefits also to education. So this is our mission. So how do we do this? So the idea is basically to take these new data sets that we get from millions of students interacting with online learning platforms every day. We combine that with new machine learning techniques that can effectively learn from this data set without relying on a lot of human annotation and tagging and human heuristics, and instead learning directly from the data. And we combine this with the user experience, design and so on to get this personalized learning experience. So today I will talk about three main sort of aspects of this that we're working with. So first is personalized content. So where we can basically take, instead of teaching to the middle, we can adapt the content that we sort of show to a student based on their current level of knowledge, in particular in each underlying concept. So that we can also adapt the pace to how fast they're learning and so on. And then the other way we can use this kind of data, except for adapting like the path to each particular student, we can also use it to derive actionable insights to teachers and content creators. So the teachers can keep track of who has struggles with a certain concept and also know what action they can take to sort of most improve the sort of average or the total of the knowledge in the class. And then for content creators, you can get insights from this if there's particular questions that are ambiguous, is there some part of the content where you need to add more theory, and so on. So that's the two sort of sides of this coin. And then I will talk about our pronunciation feedback system. So in addition to this personalized learning, we also have a pronunciation feedback system and speech scoring system, which allows you to create these personalized language learning applications. Okay, so I will start with Stana Learn. Stana Learn is our platform for creating these personalized learning experiences. So we don't create any content ourselves. Instead, we sell this as a service to companies, so they create the content, and then with simple APIs, they can basically call our platform and get recommendations and get model results and so on in real time, so that they can very easily create these personalized experiences. Basically, I will talk about a few of the aspects that come into this. So the first aspect is that we need to model the sort of proficiency of the user. So we saw in a previous talk about these knowledge tracing models and so on. So to do this very effectively, we need to take into account both the students. So we need to model the student, but we also need to model the content so that we can sort of discover the underlying aspects or concepts that are in the material, rather than relying on these handcrafted rules. With this, we can discover the knowledge gaps, the strengths and weaknesses of each student, and the pace of learning and so on. And we can have this all in a model. And the second part of this is, in addition to just computing this for a particular sequence of sort of interactions with the user, we want to be able to adaptively assess their knowledge. So with as few items as possible, we want to figure out what they know and what they don't know. So again, we rely on these rich models of the students and the content, where we take into account sort of correlations between different questions. We can also look at the content in the actual material to do this, and then we can look at past interactions of all the students to learn sort of these rich models of the students. And then we can use this to measure sort of how informative each question is. How much new information do we get from each question about the underlying knowledge state? And then we can, by doing this, we can reduce the number of questions we need to ask in order to sort of get the information we need with sufficient accuracy by up to 80 or 90% in some cases. So as we get more and more interactions from each user, we learn more about what they know and what they don't know. So we can predict with high accuracy, after sufficient number of interactions, we can predict what questions they will be able to answer and what they won't be able to answer. So we can compute the probability of a correct answer of a question. And then we can use this to sort of adapt the difficulty level to the user. So we can see, and then we see empirically that if we give a question to a student which is not too hard or not too easy, we get the maximum engagement and maximum learning. So empirically, we've seen something around 70% probability of answering a question correct is when the students get most engaged. So they don't get bored because it's too easy, and they don't give up because it's too hard. So this is where sort of you have this, you want to uncover the knowledge of the students, but you also want to take into these user experiences into account so that you can sort of optimize the trajectories of the student to keep them engaged and not leave the platform and go to YouTube or something. I mean, there's good stuff on YouTube as well, but many kids probably don't go to those sites. Yeah, so as we saw in the previous talk, we can not only predict what the student knows at this particular point in time, but we can also predict how they will remember the content over time. And this is interesting times now, because we can move away from these heuristics and like simple formulas for decay that were devised based on Ebbinghaus's work, and which basically look very similar today, except that now we have some reinforcement learning stuff and like that. But the cool thing now is that we can actually look at the real data and see exactly what the forgetting curves look like. So if we take, for example, language learning, we see that a Swedish person learning English has a very different sort of forgetting curve for different words. So if you take a word like ubiquitous, which is very strange for us, based on the spelling and the pronunciation, you might have to repeat that word 15 times perhaps to really recall it. Whereas a word like camera, which is kamera in Sweden, is a very similar word, so you only need to see it maybe once or twice. So basically we can model these curves for each item, and also using the context, like what kind of student is it, and so on. Then we can learn these to fit these models from data. And then we can optimize sort of optimize the spaced repetition to show the items at the right time. Yeah, so if you combine these and other aspects of human learnings, we get these sort of personalized learning experiences where each student can sort of follow their own path through the material. And we can optimize for different learning goals. So that sort of, if you want a test prep, and we know when the test is, we can optimize for that. We can optimize for mastery of each concept. And we can optimize for just long-term retention. Yeah, so that was Stana Learn. A very brief overview. If you want more details, you can talk to me later. Now we'll talk about Stana Voice. This is our state-of-the-art speech scoring and pronunciation feedback system. It is based on end-to-end deep learning. So we take an audio signal from where a user says something, and then we sort of run it through our neural network, and then we get a score for the phoneme level, syllable level, and word level, as well as overall pronunciation quality, fluency, and so on. So we can sort of get these scores for these different aspects. And again, we don't provide the content here. We have this system where you can, through an API call, you get this back, and then you can build sort of your own language learning experience on top of it. So here's just a very simple screen of how it could look like, where a user said, we are roommates, and then you see an overall score, and you also get, for the word that they mispronounced, you get sort of the actual parts of the word where they had trouble. And another way this could look like is...
She is my mother, and he is my father.
Try mother one more time.
Mother.
Well done. You're truly progressing with the TH sounds.
So this is just a demo. If you want to have a live demo, you can come up to me later. I can write it on my phone. So this gives you basically a personalized sort of adaptive tool for practicing pronunciation, where you can focus on exactly the things you need to practice on. And when you combine this with Stana Learn, we can basically create these adaptive personalized learning sessions. So we can do an adaptive assessment where you basically say a few sentences, and then we can score the different words and syllables and phonemes, and then we can basically measure where you have the most trouble, and we can create an adaptive session where you have to focus on only those things. And users really love this. So basically, if you this graph is a recent analysis we did for one of our clients. So it shows that the important thing what it shows is that if you're a low proficiency user, so you start out with pronunciation problems, after about 2 weeks on the platform, you've improved your scores on average by over 30%. And they really like it. So they spend a lot of time basically trying to just nail the pronunciation. And they find sort of this sort of syllable level feedback. They find it very useful and allows them to practice and focus on exactly the right things. And again, sort of another view, or the flip side of this, is that you can, in addition to create this personalized experience for the user, you can also get insights on your content. So when you create this language learning app, you can get insights on what this particular group of students find most difficult. So here we have one example where you have problems with the TH sound and the Z pleasure sound there, and then so that you can use this information to create content that matches what your population of students needs. So you can do this by basically slicing and dicing your different user groups and find out sort of what content makes most sense for them. And one other interesting thing about this, I think, is, which I'm really excited about, is that we can move away from these, like basically if you look at a lot of research in education, you have to rely on these very small scale experiments in a lab where you have a few psychology students or college students that go through some simple exercises. But when you have all this data, we can actually start looking at what is actually working and what is not working. So this is a very simple kind of early analysis we did for one client, where we see very clearly from the data that if you, to improve your final test scores, it's better to focus like broadly, like you learn a few things across all of the material rather than really nailing certain subsets of the material. We also see that by doing consistent practice rather than really focusing hard on a few days, even if you spend the same amount of time, it's much better to do this consistent practice. And I mean, these kind of examples are very simple things that I think we sort of already knew in some sense, but we can also use this kind of data to generate new hypotheses that we can then test with randomized control trials or A/B tests, so that we can actually learn and optimize the system over time to improve those aspects of learning that helps most. Yeah, so that was sort of a very brief, quick overview of what we're doing. So our vision is to personalize learning for everyone, everywhere. So we're based in Stockholm, Sweden, but we work with companies all over the world. And we're also very interested in hiring people. So if you're interested or want to go to Stockholm, you should come talk to me. Thank you.
Thank you very much.